The next thing then in the assignment is to find the margin of error. And for this, I know this is a lot of repetition, but sometimes you kind of need this for practicing on the confidence intervals. For this, you have to do a different confidence interval for each different color of M&Ms. So I'm going to go back to my data that I had here. Now, it doesn't say in the assignment anywhere that you actually have to calculate all this stuff by hand. It does give you the formula, but you can also use StatCrunch if you want to. Let's see, let's calculate the confidence interval for the green M&Ms. Okay, so for the green M&Ms, my sample proportion is just that relative frequency that I figured out for my data collection assignment, so I already have that. My sample proportion is just the proportion of green M&Ms that were in that sample, so it's the relative frequency, so it's the 0.1261. And yours is going to be different. This was just my sample. So the sample proportion in the formulas we have is the p hat. Okay, and let's go back to the margin of error formula. This is the formula that I'm going to use. Now the nice thing about this with the design choices I made earlier is that I already figured out my z alpha over 2. So that I already have. It's what I used in the sample size formula, so it's 1.96. So my p hat, this is coming from my sample, so I've got that, and then my sample size is the n. So in my case, that was 349. So all I'm going to do is plug these things into this formula and get my calculated margin of error. So I have the 1.96 there, 0.1261 here, 1 minus 0.1261, and then divided by my sample size. One thing about this, when you're calculating this, is that that sample size, the n, actually goes underneath the square root. So when I put this in my calculator, I'm going to put it in just like that, all in one step. That way I don't have to worry about how much to round. So I've got the 1.96 and then the square root. The only thing about this is that you have to be careful how many parentheses you put in there. So notice I did put parentheses around the 1 minus 0.1261, just like it was in my formula. And then I need another parentheses at the end. Okay, so that gives me 0.034. And for your margin of error in this, you should round it to 3 decimal places. Oops, which would be 0.035. I just looked at the first 3 of those and I didn't notice the next one was an 8. So this one, round it to 3 decimal places. Okay, so that gives me my calculated margin of error. So then the next thing is to actually figure out the lower and the upper limits for my confidence interval. So my lower limit is my sample proportion, which was the 0.1261 minus the margin of error. My upper limit is my sample proportion plus my margin of error. So I've got the 0.1261 minus the 0.035 and the 0.1261 plus the 0.035. Which gives me 0.0911 and 0.1611. Now these also, for the limits, we're going to round these to 3 decimal places also. So I'm going to round this to 0.091 and I'm going to round this to 0.161. Okay, so one thing about these, notice these are still in proportion in decimal form. If you want to list these as percentages, that's okay. Just move your decimal point over 2 places. Now that we're done with all those formulas, we can turn these back to percentages if we want to. Eventually, not in this assignment, but in next week's assignment, we'll be comparing these to what they had in the Mars Company letter. So in that case, since those were percentages, then we'll probably want to list them as percentages. So we could say this would be 9.1% and this would be 16.1%. Okay, so that would be for my green M&Ms. To do my other ones, I would just go back and I'd have the same Z alpha over 2, the same sample size, so the same N. The only thing that would change for the other colors would be my sample proportions. Okay, now let's look at how we would do this with StatCrunch. And this is actually not too hard. You just have to go to Stat and do Proportion Stats. We're just looking at one sample, and what we have is a summary because we already have all the numbers. We're not working off of raw data. So I would do one sample with summary. Okay, so for this, I need my number of successes and my number of observations. So number of successes, in this case, would be the number of green M&Ms I had. And here we're not dealing with a proportion, we're dealing with the actual number. So if I go back to my data over here, my actual number of green M&Ms was 44, so that's my number of successes. By number of observations, they mean the sample size, so for me that was 349. And then what I'm trying to do is a confidence interval, and this lets you put in the confidence level you chose. So it automatically puts in 0.95 since that's kind of a standard one, and that is actually what I had used for my confidence level, so I don't have to change this. If I were using a different confidence level, then I would put a different number in here. Okay, and then that's all you have to do, and it does all the work for you. So this comes out, it tells you what your sample proportion is, which is the same as what we had over here, the 0.1261. And it gives you the lower limit and the upper limit for your confidence interval. Now, and here where it says the standard error, that's actually part of our formula for the margin of error. Let me go back here and show you what part that is. So that's the part of the formula without the critical value. So this part in here, inside of the square root, this is actually your standard error. So you could kind of check yourself if you're trying to do this by hand and then check it with StatCrunch. If you just do this part of it, that should come out to be the same value they got for the standard error right here. And then to actually get your margin of error, you'd have to multiply that times your critical value. Okay, but this does come out with the same lower limit and upper limit that we found. So the 0.091 and the 0.161. So that's just a way you can do it. So again, to get there, you go to Stat, Proportion Stats, one sample with summary, then put in your number of whatever color of M&Ms you're talking about, number, not proportion, Your number of observations is the same as your sample size, and then click confidence interval, and then put in your confidence level. That's all you have to do for that. Okay, so the last thing on the assignment is to do statements for each one of the confidence intervals you find. So again, you're going to repeat this process of finding the confidence interval 6 times, once for each color. And then for each one of those, you're going to write a statement saying what the confidence interval actually was. And I gave you a standard form that you can use in the assignment. And that's basically like this. It's going to say I am, and then you put your confidence level in here. So for me, since I used 95%, I would put in 95%. Okay, and then for a confidence interval statement, we want it to be specific about what population we're talking about and what parameter we're trying to estimate. So in here, I want to put in here somewhere what variety of M&Ms I had. So I'm going to say that for plain M&Ms, the true population, and here if I'm using proportions, so if I'm using it in the decimal form, I'd say proportion. If I'm using percentages, I'd say percentage. And then I want to say what I'm talking about. I'm talking about the green M&Ms right here. So you're going to write one of these statements for each different color. Okay, so the true population percentage of green M&Ms is between, and then I'm going to put down my lower limit and my upper limit. So in my case, it was between 9.1% and 16.1%. Okay, so in the assignment, you're going to do this once, and you can copy and paste these. I know you don't want to have to type this out 6 times, but I do want to see 6 different statements. Everything in here is going to be the same except the color is going to be different for each one of your statements, and then your numbers are going to be different for each one of your statements. Okay, one more thing to notice about this. I was saying that what you chose in the beginning for your maximum margin of error isn't going to be, it shouldn't be the number that you actually come up with for your margin of error. So let's go back and look at that. Up here, I decided to choose 6% for my maximum margin of error. And I said here my margin of error should be no larger than 6% or 0.06. What I actually came out with for my margin of error was 0.035. So that was actually quite a bit smaller than my 0.06. That's not too surprising because this came out with my minimum sample size of 195. My sample size is quite a bit bigger than that. The bigger your sample size actually is, the smaller your margin of error is going to get. So if my sample size is a lot bigger than my minimum sample size that I came up with here, then my margin of error should be quite a bit smaller than what I chose for my maximum.